Good morning to all and welcome to Byju's exam prep. So hope I am audible as well as visible to you all. Please confirm that. Done. Okay. Morning to all. So I have asked them. So again, I'll tell them to make uploading of the PPTs. Okay. So we'll start the today's session. Yesterday, that is last session, we discussed something about the tropical cyclones. More specifically, we discussed about the impact of that. And in defining the impact of the tropical cyclones, I told that whenever the tropical cyclones make landfall, so this is after the landfall. So, and whenever the tropical cyclones, when it makes landfall, post landfall, we always find three events are associated with that. One is the storm surge, second one is the wind, and then the rain. Now, these three combinedly bring large amount of socio-economic losses. Combinedly make socio-economic losses. So this you should remember. What happens when there is surges? What happens when the velocity of winds are more? What happens when there is heavy rainfall? On the coastal communities. Right. So this you should remember. And wherever the density of population is more, wherever the economic activities are stronger, so those areas are the one which are most affected. The areas where population density is more. Population density is high. Plus, the area where large amount of economic activities are there. Economic activity, say like industries or manufacturing or some secondary or tertiary type of activities are there where they have invested huge amount of money there. So in those areas where large amount of economic activities are there, losses will be in high degrees. So population density, economic activity, then shape of the coastline. Shape of the coastline. Now, if the coastline is narrow and elongated, then the impact will be very high. If the coastline is broad, then the impact will not be that strong. So if the coastline is broad, then the impact of water will not be that high. So less impact. But if the coastline is narrow and elongated, like the one what we find in Indonesia, Gulf of Kutch, Gulf of Mannar, etc. So where the coastal area is narrow and elongated. So we refer this as a narrow and elongated one. Narrow and elongated. Now, wherever the narrow and elongated coastlines are there, after the impact of cyclones, the waves will be of highest level. So this will create highest waves. The height of the waves will be more because the waves will compress there. The water will compress and it reach to great height. Now these characteristics makes the losses or determines the losses. the losses. Now, sometimes when they ask about the cyclones, something about the cyclone, it is a depression, or when the wind velocity reaches to more than 62, we refer that as a cyclone. A low pressure center where the air circulates surrounding. So we refer that as a cyclone. But these things you should remember. As you are writing answer in disaster management, the factors which determines is this. Apart from that, the vulnerability profile is also very important. Rich, poor, aged, young, and all. Right. So you should keep this in the mind. Vulnerability profile. Right. So any answer whenever you are writing, you should remember the regional approach of that area. Right. So these things makes the cyclones more dangerous in one area and comparatively less dangerous in other areas. So please keep these points in the mind. Right. Now, when we talk about the cyclones, you should remember that this cyclone is something which is weather based. Cyclone is a natural disaster which is based on change in the temperature. So hence we refer that as extreme weather based phenomenon. And as it is associated with the movement of the wind, variation in the temperature. So all disasters which are associated with weather, that is extreme weather conditions like heat waves, cold waves, cyclones, etc. Extreme weather, example, heat waves, cold waves, cyclones, droughts, etc. So wherever extreme weather conditions are associated with the development of that particular disaster. So in this case, you can have early warning systems, which can be a very predominant one. So such type of disaster managements, when we see, pre-disaster management plays an important role. So in this case, pre-disaster management plays an important role. And in the pre-disaster management, when we talk about pre-disaster management, you should remember that 3 subdivisions of pre-disaster management. One is prevention. Second one is something which we refer them as mitigation. And the third one is adaptation. Now, mitigation and adaptation are the 2 activities where we can't prevent that type of the impact here. So among the prevention, very significant one which is associated with all weather part, right? So generally when we say adaptation, perfect, you can use the term preparedness. Appropriate word is preparedness, as we have done with that. So we can say preparedness, which is more appropriate. So if you mention adaptation also, no problem. But preparedness is very perfect one, Bhimrai. Perfect, not an issues. So when we say the prevention, in the context of prevention, when we come across extreme weather-based conditions, you should always remember early warning system plays an important role. So here, early warning plays an important role. Because you can detect the movement of the wind patterns. You can detect the change in the weather characteristics. So hence, early warning system plays an important role in the context of weather-based. Now, there are many disasters where weather-based conditions are not there. Take an example of earthquake. So in the earthquake, we don't have early warning system. But the impact of earthquake can be reduced by preparedness or mitigation. More specifically, is it clear? So always remember, whenever when you are writing answers on the context of extreme weather conditions, you should always keep early warning system. And these early warning systems should always be updated. They should always be increased in its efficiency. These are all consisting of the same format, but you have to be very careful in mentioning which type of disaster you are explaining, whether it is weather based, whether it is something associated with the non-weather phenomena like earthquake, volcanic activities, etc., or whether you are talking about man-made disasters or socio-natural hazards. So whenever when you are writing your answers, first you make up your mind that whether it is a man-made or whether it is natural. Again, in the context of natural, weather-based or non-weather based. Then socio-natural hazards like landslides, where the impact of man and the natural both are seen. So if you prepare this mind map, then you won't have any problem in answering any type of questions which are asked in the context of disaster management. Is that clear? So please understand these perspectives. Is it clear? So regarding the UAE floods, so at the end of the class, I'll explain that. So it is a very simple thing. There are many theories which are given to that. One is that it talks about something called as large amount of cloud seeding which have been done. Generally in the desert areas, cloud seeding activities is one which is important to bring the rainfall. Why? The reason is there you don't have proper aerosols. Aerosols are nothing but the solid or liquid particles which plays a nuclei of condensation, small particles, nuclei of condensation, and surrounding that the condensation takes place. So when they spray the silver iodide or dry ice, so during any type of cloud seeding, either silver iodide or dry ice is used. I'm repeating, silver iodide or dry ice is used. Now what happens is, whenever when they use the silver iodide or dry ice, then it will create a place where the condensation starts. It is something like this. You have prepared a tea. You have to need a cup where you can pour the tea and drink the tea. So without the cup, you can't drink the tea. So it needs a platform where you have to put a tea and then you can drink. Now, in the context of such areas, when we talk about the deserts, or even in context of India also, wherever then we find no or very weak or very less amount of aerosols, we have to artificially inject these type of aerosols. And injecting these aerosols like silver iodide or dry ice, we refer that as cloud seeding. Cloud seeding. Now these silver iodides or dry ice, they act as an area along which the condensation takes place, and that condensation which increases will create the clouds, and those clouds are something which provides heavy rainfall. So generally the rate where the impact of cloud seeding can provide rainfall is not very high. It is somewhere around 30%, 40%. It is depending on certain parameters. Sometimes you may get heavy rainfall, sometimes you may not get rainfall also. But in the context of Dubai, every time they spray this, so this might be one of the reason which has created huge amount of the rainfalls in a very short period of a time, which we refer them as cloud bursting. Plus, changing of the climatic conditions, the wind patterns have changed, they have accumulated, and that is where we find strong condensation has taken place. That is second thing. Third thing is, the losses in the Dubai are more because that is an area which is never expecting heavy rainfall. So their preparedness is not of the mark what the flooded areas are there. So as they have experienced that for the first time in last 75 to 80 years, so their preparedness was not ready because they were not ready to get this type of rainfall. So hence the casualties were increased. This is something which is associated with the UAE perspectives. Is that clear? Okay. Now coming back to the cyclonic perspective, always remember early warning system plays an important role. Now in the context of early warning system with reference to cyclones, with reference to cyclones, we always talk about something called as naming of the tropical cyclone. One of the important aspects is naming of tropical cyclone. Naming of tropical cyclone. Now, we have names for the tropical cyclones. Like, so when we say the cyclones, temperate cyclones and tropical cyclones are there. The tropical cyclones are named, but not the temperate cyclones. You can take an example of Biparjoy. You can take a name of Freddy, right? So all these are the tropical cyclones. So the tropical cyclones are having the names because their life itself is 3 to 10 days, but we don't have the name for temperate cyclones. Now, what is the impact? There are many. Michang is there, Biparjoy is there. So there are many are there where we have the names given to them. Freddy is one in the South Indian Ocean, right? So we have many types of them. We have many of them which are been named by the countries there. Now, the idea of naming of tropical cyclone is which will make ease of communication between the forecaster and the common people. So naming of the tropical cyclone is which will make ease of communication. Ease of communication in between forecaster and the common people. Common people. Is that clear? Now, when we say why the temperate cyclones are not named, temperate cyclone formation is totally different. They extend for a longer period of a time, right? And the impact is also not that high. Impact is also not that high. They are human friendly. Whereas these tropical cyclones, they create huge losses. And these tropical cyclones are associated with the hazards which convert into disaster. Is that clear? So this is your geography part, but still remember, naming of tropical cyclone is important aspect of the early warning system in the context of cyclone. Okay, so here we'll move on to the same thing. Now, the National Disaster Management Guidelines, which were given in the context of cyclone risk management, all things remains the same. Only the terminology changes. Non-structural measures and structural measures. In the non-structural measures, early warning system plays an important role. And in the context of cyclones, naming of tropical cyclones is one. Then communication and dissemination. So this should be very effective. Effective communication and dissemination is very, very important. Now, this can be done. Effective dissemination can be done through many bulletins or through radios, etc. Sometimes they use the apps through which the information is shared. Information is shared. Now, the idea behind early warning system is whatever short time is there, so within that they prepare themselves. So it gives that time, 1 hour, 2 hours, 3 days, etc. So in that short period of a time, the communities get prepared themselves. So this is important aspect of early warning system. Then management of the coastal areas. So generally these cyclones affect the coastal areas. So you should always manage the coastal areas that they are very systematically and robust are there. They are very systematic and robust. Robust means strong. And when we are talking about managing of the coastal areas, you should remember there is something called as coastal regulation zones. Now, this you have already studied in the context of ecology and environment. So in the ecology and environment, I told that the coastal regulation zones, which classified all the coastal areas in the year 2011 into 4 zones. And again, they were updated in the year 2018. They were revised in the year 2018. And the idea of coastal regulation zone is where they restrict certain type of activities. They regulate certain type of activities. So this is to restrict and regulate certain activities. Right. Then awareness generation is very, very important among the people. So it can be creating their capacity development. Now, awareness can be by giving them proper training, by giving them proper information, by training, by giving important toolkit which are necessity for the activities, and also creating proper coordination. Proper coordination. Now, these are non-structural measures. Now, what are structural measures? Now, in the context of structural measures here, structural measures includes engineering structures like creating of artificial embankments, creating of artificial embankment, then we can create natural embankments, creating natural embankments. Any example of natural embankment? Artificial embankments means we use bricks, we use irons, we use steels and construct the height of the banks or the coastal areas. Now, natural embankments includes, no, I'm asking about examples of that. Natural levees are nothing but natural embankments. Example is mangroves. Right, which we refer them as natural embankments. Planting more number of the salt tolerant trees there. So we refer them as natural embankment. Then third, creating shelters. The people who are affected, for them creating shelters, etc. So we refer them as the structural measures. So understand the vulnerability profile, then risk management, and then about structural measures. Then we also created something called as the National Cyclone Risk Mitigation Project. This is very important. And the idea is always update the preparedness to have a proper system of coordination between the forecaster, common people, and also the communities which are associated with the disaster management there. And this project also creates awareness along with increasing their capacities in the context of any such disasters. So it is about enhancing early warning system, increasing their capacities, and updating the systems by using many technologies like satellites or sometimes mobile apps, etc. Right. Now, in the context of India, these are the basics. When we talk about early warning system, there are 3 area cyclone warning systems are there. Chennai, Mumbai, and Kolkata. Chennai, Mumbai, and Kolkata. Then we have 4 cyclone warning centers are there. Ahmedabad, Thiruvananthapuram, Visakhapatnam, Vizag, and Bhubaneswar. So remember these early warning systems, because in the context of weather based, early warning system plays an important role. Early warning plays an important role. So they disseminate the information. Now, when we talk about that, certain statements which can be important. The accuracy of weather forecast and their effective dissemination is a continuous process. It is not one time. You have to give this continuous, because when we talk about the disaster management, I told that it is a continuous cycle. It is a continuous cycle, which is seen in the context of any such. Now, here we have used a program called as across. Across. Sometimes in prelims they may ask, right? So atmospheric and climate modeling observation system and services, right? So here it is upgradation of the forecast services, where the development of advanced operational forecast system initially, which is prepared and disseminated to the local people. Then upgrading and sustaining the communication associated with weathers. Then capacity building and outreaching. Outreaching means effective dissemination. Effective dissemination. Now, this is where you have to be very careful in your writing capacities. You don't have to elaborately explain all these. You can use the words there, like across, and the terminologies like effective dissemination, etc. Right. Now, don't worry about that cyclone warning systems and ones. Just remember that we have early warning systems. We have early warning systems. Right. Then this is something INCOIS, that is Indian National Center for Ocean Information Services, which provides early warning systems associated with storms and cyclones. So please remember this. So here you will come across large amount of content. Large amount of content. See, Varun Mitra apps and all, they give that information. So many apps are there. Any updated thing you can put them. We will have many such, like Quake app is there, Earth app is there, Sagarwani app is there. So many apps are there. Right. Now this is set up in Hyderabad. It is in Hyderabad. Right. Now the major objective of this is to forecast or to give early warning system by which the communities are prepared themselves. So don't elaborate them. This content is more than sufficient for you to read and write in your answer writing. Then this INSOIS has developed a device called as Gemini. And this Gemini works with Gagan, India's GPS system. India's GPS system. So this is your SNT. Right. So Gemini is Gagan-enabled instrument, which receives the information from Gagan. So Gemini receives information through Gagan. Gagan is India's GPS system. India's GPS system. Updated one. Apart from that, if successfully when we launch NISAR, then NISAR will also be giving more information. So after that, if it is launched maybe this month or next month, you can add NISAR also. NISAR also, which will help in providing the data, and these data can be significantly implied in creating forecasting. So all the data which are received by them, are used in creating a forecast. So collection of data is very, very important. Now, from where you collect the data is significant. Whether you are collecting through Gagan or whether you will be connecting through the NISAR. So they all plays an important role. And these data help in creating an effective early warning system. So that should be kept in the mind. So this is more than sufficient. Don't make research on that. Then National Cyclone Risk Mitigation Project. Now the idea is to check the preparedness and to check what you are doing in the later stage of resettlement and rehabilitation. Right. So when we talk about these projects, so this always talks about two entities. What we are doing in the context of risk management, what we are doing in the context of crisis management. Crisis management. Remember, risk management is pre-disaster management, and crisis is post-disaster. Pre-disaster, post-disaster. Now, in the pre-disaster management, we always talk about preparedness, prevention, mitigation. And in the post-disaster management, rescue, rehabilitation, research, etc. Right. So the cyclone mitigation project will talk about the same thing, upgrading the early warning system, effective dissemination. It also talks about having proper communication and coordination between different institutions. Now, they all work very well only when there is a proper coordination. Coordination. Is that clear? So here it talks about the same, improving the early warning systems. The same thing you will find again and again, the same statements. Enhance capacity of the local communities. The same. So whatever we are started from the first day, the same you will find. Excess of emergency shelter evacuation. That is the moment when we talk about the cyclone which was made landfall. So during the landfall, we refer them as emergency services. Right. Then strengthening the disaster risk management capacity at central, state, and local. It means proper coordination is required. Right. Then enable mainstream of risk management as an agenda in all the policies. So once you have made a chart, then it becomes easy for you to remember them for the longer period of the times. Every disaster management remains the same. Right. Now, 4 stage of cyclone warning. Sometimes they may ask for 10 marks. The first one is pre-cyclone watch. So generally, this pre-cyclone watch, which is released 72 hours in advance. We don't say coastal specific. So whatever, yes, this project is coastal specific. This project is coastal. It is associated only with the coastal part. Now, pre-cyclone watch. Generally, this is given about warning of formation of cyclone. So this gives warning of formation or development of cyclone, which is given 72 hours in advance. Then cyclone alert. Cyclone alert, it talks about giving the information of location and intensity of cyclone, which is released 48 hours in advance. So cyclone alert is about location and intensity of cyclone. Intensity means strength of the cyclone, location and intensity of the cyclone. And this is to advise the fishermen that not to enter into the sea. So it is advice to the fishermen. Right. Then the third one is referred as cyclone warning, 24 hours in advance and 3 hours interval. Every 3 hours, the cyclone warning is done. And this cyclone warning is about giving something, forecasting about the landfall. Forecasting of landfall. So the idea behind this is, this will make the authorities to prepare national disaster response force. So these national disaster response force can be deployed for rescue and rehabilitation. Right. So this is something which is very, very important. Then post landfall outlook, 12 hours in advance. Now the idea of post landfall outlook is, it is about expected time of landfall, whether it is morning, whether it is night or whether it is in the afternoon. So it gives expected time of landfall. Time of landfall of cyclone. Yes, pre-cyclone, they give, so pre-cyclones and all, they are certain which we study. So whenever when we say pre-cyclones and all, they give some idea about why they are increasing, and they use them for creating risk analysis. In the risk factor, I told that studying previous cyclones, right? Now, whenever when we talk about these 4-stage cyclones, they always are associated with the color codes. Now, cyclone alert is associated with yellow color. Cyclone warning, orange color. Then post landfall outlook, it is red color. Red color. Now, sometimes they may ask the same questions in your prelims also, and sometimes in the mains also, because India is the country which is affected most by cyclones. Please remember these 4-stage cyclone warning. They may ask in mains directly, write a note on 4-stage cyclone warning and why the number of cyclones are increasing in the context of climate change. Right. Now, associated weather with cyclones. If IMD releases green, IMD, Indian Meteorological Department, green color code, so it means no problem in that areas. If it releases yellow color code, it is possibly it will have an impact. So be prepared for that. So that is their intention. Then when they say orange color, so orange color means be ready and be alert. Red means 100% that the cyclone will make landfall in that area. So these are the color codes for the weather associated with the tropical cyclones. Now don't confuse. These are cyclone warning color codes. These are associated weather color code. Associated weather color codes. Don't get confused. Cyclone warning is different from associated color codes. Right. Now we moved on to earthquakes. This you already studied in geography, just brief of that. Earthquake, in a simple term, we say it is the vibrations. It is a vibrations. Or we say jolts. Jolts. Or we say tremors on the surface of an earth. Vibration, jolts, tremors, or shaking of the surface of an earth due to sudden release of energy from the earth's interior. Sudden release of energy from the earth's interior. Now, whenever when the earthquake is there, it is the release of stress. Now, whenever when the stress is released, it is associated with many factors, maybe natural, and sometimes we may find man-made factors are also there. But when we say the stress is reflected in the form of breaking up of the rock strata there. Now, whenever when the rock strata breaks, we refer that as faults. If this is big rock, so wherever this rock breaks, so we refer that as fault. Fault or fault line of earthquake, breaking off that. Right. Now, in the context of earthquake, we always come across the term the energy released, the point from where the energy is released. The point from where the energy is released, we refer that as focus. And this is also referred as hypocenter. And the point which is exactly above the focus, we refer that as epicenter. So focus and epicenter. Now, from the focus, energy is released. in the form of waves. In the form of waves, we refer them as seismic waves. Seismic waves, right? The energy which is released from the focus, we refer them as seismic waves. And these seismic waves, they move in all the direction. They move in all the direction from the focus in the lithosphere part. In the lithosphere part, right? Now, next thing is, whenever when we talk about the earthquake, we always talk about two terms called as magnitude and intensity. So please understand these two terms: magnitude and intensity. Magnitude talks about the energy released. Energy released. And the intensity talks about the impact of that energy. Impact of the energy which is released. Or it is associated with losses and damage. Associated with loss and damage. Right. So it is something like this. Magnitude means, example, if you are slapping somebody, we refer that as magnitude. So it can be slapping, just a slapping phenomenon, we refer that as magnitude. Now, intensity defines that how hard that slap is. That is, whether the slap was very strong or whether the slapping is with a low care and concern. Because two ways the slapping can be there. One is with low care and concern, and one is with very strong impact. Now, these defines the losses. If the slapping is very hard, then the losses will also be very hard. If the slapping is with love and care, then it will not have negative impacts. That's where we say intensity talks about the impact of the energy which is released. And energy released is referred as magnitude. Magnitude defines only the energy released, whereas intensity defines the impact of the energy which is released, and it is used to calculate the loss and damages. So in the disaster management, intensity plays an important role. Intensity plays an important role. Second, magnitude is calculated by a Richter scale. It is calculated by a Richter scale, where the values are represented in logarithmic. The values are represented in logarithmic or exponential, that is to the power of 10. Exponential, that is to the power of 10. And here in the Richter scale, it is always have a scale 1 to 10. 1 to 10. But the intensities are calculated in modified Mercalli scale. Modified Mercalli scale. And they are expressed in Roman values. And the scale is 1 to 12. 1 to 12. So this is what we refer them as intensity. Now, if the scale says 1, the vibrations are not felt. If it says 12, damage is completely total. So based on the impact of the energy released, this modified Mercalli scale is given. 1 is least and 12 is highest. Least and highest. So please remember these two terminologies: magnitude and intensity. Now, when we talk about the earthquake, I told you it is released in the form of waves. And when we talk about the waves, there are two types of waves: body waves and surface waves. body and surface waves. Focus on understanding body and surface waves. Body waves will originate from the focus, and surface waves are generally from epicenter. So please remember this. Now, what is the relationship between body waves and surface waves? There is a relation. There is a relation between body waves and surface waves. What is that relation and why they are associated with losses? Surface waves are associated with losses. Now, if you take this as a point called as focus, and this is epicenter. So from the focus, the energy is released. And this energy is released in the form of body waves. Right? And these body waves are of two types. That is P waves and S waves. And this you have already studied in geography. P waves can travel in the solid medium as well as liquid medium. And S waves can travel only in the solid medium. So P waves and S waves. P can travel in solid. It can travel in liquid also. But S only in solid. And P waves are faster. The velocity of P waves are faster. They are faster than S waves. So the first wave which is reaching at the epicenter, first wave which reaches at the epicenter is P waves, followed by S waves. So from the focus, P waves, S waves, P waves, S waves, then P waves. So first P waves will reach to the epicenter. Right? P waves will reach to the epicenter, followed by S waves. Right? After that, understand this. When the body waves reaches to the epicenter, when the body waves reaches to the epicenter or surface, part of body waves are converted into surface waves. Part of body waves are converted to surface waves. Right. So part of body waves are converted into surface waves. Now surface waves are of two types. They are of two types. One is love wave and second one is a Rayleigh wave. Now, what is love wave or what is Rayleigh waves? What is their nature? How they propagate? Propagate means how they travel. Propagate or how they travel. They are very interesting to be known. The moment when the body waves reaches to the surface waves, they start grazing to the surfaces. They never come back. Propagate and traveling. Body waves reaches to the surface, then they graze along the surface. They never come back. They never enter again to the Earth's interior. Propagate means traveling. Now, how the love waves travel? Love waves travel like zigzag. If you see love wave, they travel zigzag. It is like snakes. Zigzag. Love waves travel like snakes. Then Rayleigh waves are like rolling. Rayleigh waves are like rolling waves. in the oceans we find the waves are produced. The same types of characteristics waves are produced in the Earth's surface. So they are rolling type waves. And this Rayleigh waves and love waves, they are responsible for collapsing of the infrastructures. So these love waves and Rayleigh waves, because of their nature of propagation, these are associated with making damages to the standing infrastructure. So they will lead to collapse or damage to the infrastructures. Now, when the buildings collapse, when the infrastructures collapse, so these debris will create injuries and deaths. So this in turn creates injuries and deaths. Debris will create injuries and deaths. Is it clear? So please understand these two terminologies. So there is always a relationship between body waves and surface wave. Part of body waves, after reaching to the epicenter, they convert into surface waves. They are love waves and Rayleigh waves. So there is a relationship between body waves and surface waves. If the body waves are stronger and if they reach to the epicenter faster, then the surface waves will be very, very strong. And if the surface waves are strong, then the intensity will be very strong. And if the intensity is strong, then the losses will also be very, very strong. Then the losses will also be very, very strong here. See, when we say yes waves, you don't take about yes waves. So when we talk about P waves and yes waves, so P waves and S waves, when you read, they are referred as transverse waves. They are referred as longitudinal waves. Now here we are talking about the surface one. P waves, S waves. P waves can travel in the solid, liquid, but S waves travel only in the solid. The reason is their characteristics, longitudinal and transverse characteristics. One propagate along, one propagate perpendicular, right? Now here, love waves, they are something which we refer them as moving to and fro. So hence, these surface waves are associated with losses. So please remember the two characteristics of surface waves. Right. Now, when we talk about the earthquakes, understand that all the earthquakes are classified into three types. All the earthquakes are classified into three types based on the distance between epicenter and focus. These all are your geography terminologies. What happens to the body waves which are not converted into surface waves? See, here, when the body waves, if they are not converting into S waves, surface waves, they collapse. That's simple as it is. Distance between epicenter and focus. We classify the earthquake into three types. The first one is, if the distance between epicenter and focus, if it is less than 60 kilometers, we refer such types of earthquakes as shallow earthquakes. Shallow earthquake. Second, if the distance between epicenter and focus is 60 to 300 kilometers, then we refer them as intermediate earthquake. Intermediate earthquake. Then third one is if the distance between epicenter and focus, if it is 300 to 600 kilometers, then we refer that as deep focus earthquake. Deep focus earthquake. So we refer them as three types of earthquakes: shallow earthquakes, intermediate earthquake, and the deep focus earthquake. Now, always remember, we showed that there is a relationship between body waves and surface waves. Relationship between body waves and surface waves. Part of body waves are converted into surface waves. Now, in all the three cases, in which one you will find the surface waves are stronger? In all the three cases, where you will find the surface waves are stronger? If it is major earthquake. If it is major earthquake. Major earthquake means the earthquake of magnitude more than 6. More than 6 magnitude, we refer that as major earthquake. And if the earthquake has magnitude of 9 and above, we refer that as mega thrust. If an earthquake of magnitude 9 and above, we refer such earthquake as mega thrusts. Mega thrust, right? Now, when we talk about the shallow, intermediate, and deep focus, now this is very simple to be known. This is the surface, and here you are having the focus. So this is shallow. Now in the intermediate, this is the surface, and here you are having the focus. And in the deep, here you are having the focus. Now, where you will find the surface waves are produced faster, in the shallow or in the intermediate or in the deep focus. Is it clear now? So hence, where will be the surface waves stronger? In the shallow or intermediate or deep focus? Where you will find the surface waves are stronger? Very simple, right? So as in all the cases, body waves reaches here. Body waves reaches here. Now, in the context of shallow waves, body waves reaches to the surface very fast. They will reach to the surface very fast. And here, they will take more time. So to reach to the time, much of the energy is lost. So here, more energy is lost. You may not feel the vibration also. But in this case, if it is shallow, then energy is not lost. Much energy is lost. So hence, it will have strong surface waves. Surface waves. So it means that it will have strong intensity. It will have strong intensity. So hence we say intensity is associated with distance between epicenter and focus. So hence we always say intensity of an earthquake. Please understand, I'm not using the term magnitude. Intensity of earthquake always depends on the distance between epicenter and focus. Please keep this in the mind. Intensity always depends on the distance between epicenter and focus. And if the intensities are more, it means losses are very, very high. Now here you have already seen an example. Example of this is the Taiwan earthquake in April 2024. The Taiwan earthquake. Now this Taiwan earthquake, which took place with a magnitude of 7.4, and the distance between epicenter and focus here is 38 kilometers. Shallow earthquake. Again, example of this is if you take the Turkey and Syria earthquake. Turkey earthquake. which took place in 2023, where it created a huge loss. 50,000 plus life were lost. 50,000 life were lost. And here we find magnitude of 7.2 was there. And if you see the distance between epicenter and focus here, it was less than 20 kilometers. Less than 20 kilometers. So please understand these data when you're writing any type of conclusion. Shallow earthquake are always dangerous one. Epicenter is on the surface. I've explained that. Epicenter is on the surface. This is epicenter, where it reaches above. This is epicenter. Is it clear? So please understand these points. Right. If you are not done in geography, remember this. Read them properly and keep them in the mind. Is that clear? Now, defocus earthquakes are generally seen in Pacific Ring of Fire. In the Pacific Ring of Fire. In between India and Nepal, in Himalayas, we find shallow and intermediate earthquake. In Himalayas. We find shallow and intermediate earthquake. It means the distance between the epicenter and focus is comparatively lesser here. So hence, if any earthquake takes place in Delhi, which was there in 2023, even though it is of less than 5.8, the losses were seen. Is it clear? So please remember these terminologies. Now after this, one more important term you should remember in the context of earthquake, which is often seen in the news regarding earthquake. We talk about something called as main shock, then foreshock and aftershock. Foreshock and aftershock. Right. Shallows in Himalayas not threat. I never told that they are not threat. I said that Himalayas are always associated with shallow and intermediate earthquakes. I told deep focus earthquakes will not be having much impact. Himalayas are always vulnerable for the earthquakes. Right. Main shock, foreshock, and aftershock waves. Now, this is very important to be known. If you are reading your current affairs, example, in the context of India, if you take the data of 2023, in the year 2023, when you see the data, they say that India experienced three main shocks. And these three main shocks, when we talk about India, they were in three particular dates: January 24, October 3, and November 3. Three main shocks were there: January, October, and November. And after that, they say that the total number of earthquakes in the India and Nepal province, the total number of earthquakes, they say it is somewhere around 97, which includes aftershock waves also, So this is how the data is given. Or sometimes when we talk about the Taiwan earthquake, in the Taiwan earthquake, which you have read in the context of your current affairs in the month of April. So the magnitude of earthquake which hit was 7.4 on April 3rd. After that, it has experienced 29 aftershock earthquakes. 29 aftershock waves. 29 aftershock waves. Now, what are main shock and what are aftershock and what are foreshock waves? Right. So please understand this. The moment when the earthquake takes place, it can be for a days. The energy is released for a days, weeks, or sometimes for a month. The energy is released for the days or sometimes months. Small energies and sometimes high energies released. But during any earthquake which is calculated for that period, any earthquake where the energy released is calculated for that period where the continuous energy which is released. So in that, if it is for 3 months or 4 months, so within that 3 months or 4 months, one day or one particular event will release highest energy. The highest energy released which is absorbed during that period is referred as main shock. Main shock. And after that, whatever energy is released after that, whatever energy released which is less than the main shock, which is less than main shock, we refer that as aftershock waves. Aftershock waves. Now, in the context of Taiwan earthquake, the main shock was 7.4, which was on April 3. And after that, 29 aftershock waves were there. And all the energy which is released before the main shock, energy which is released before the main shock, which is also of lower value, we refer them as foreshock waves. Foreshock waves. So please remember these terminologies. Main shock, foreshock, aftershock. So aftershock will be followed after the main shock, and foreshocks are before the main shock. And aftershocks, they follow the main shock. They follow the main shock. Is that clear now? Main shock, aftershock in the context of earthquakes. Is that clear now? When you are reading your data. So this is with reference to India. Now, India experienced most number of earthquakes in 2023. India experienced most number of earthquakes in 2023. Right. Now, why India is vulnerable for earthquake? Now, in the context of India, why it is vulnerable for earthquake? Because of its geological part. We know Indian plate collided with the Eurasian plate. Indian plate collided with the Eurasian plate. It subducted beneath that. So Indian plate subducted beneath the Eurasian plate. Right. Now this collision was very strong. After this collision, the Indian plate subducted. And then Indian plate made 3 anti-clock thrusts. 3 anti-clock thrust. This is Eurasian plate. No, this is Indian plate. Anti-clock thrusts in 3 geological time frame. 3 anti-clock thrusts. Rotation. Thrust means rotation. In 3 different geological time frame. Now understand this. The first thrust created. So whenever this Indian plate thrusted that, it makes the emergence of the landform. So this first thrust created the highest Himalayas. We refer them as the main Himalayas, right? So this created the main Himalayas, or we say the highest Himalayan part, right? So generally we refer that as Himadri or Greater Himalayas or Greater Himalayas. Then after millions of the years, the second thrust was there. And the second thrust created the second mountain range of Himalayas. And we refer that as Himachal or Middle Himalayas. Then, millions of years later, the third thrust was there. Third time it rotated. And that created the third mountain range of Himalayas called as Shivaliks. So as it is 3 anti-clock thrusts, so hence we say Himalayas have 3 ranges. 3 ranges. The oldest one, the recent one. So hence we say it is a complex fold mountain. Complex fold mountain. It is somewhere around 50 to 60 million years, and this is 10 million years old. Recent one, 10 million years old. So hence we find more fossil evidences in Shivaliks. This is how the Himalayas were formed. Greater Himalayas, Middle Himalayas, and the Lower Himalayas. Now, with reference to the disaster perspective, so this is the Greater Himalaya which is created, the first thrust, the folding one. Then the second Himalayas. Then the Shivaliks. Shivaliks 1. Now, when you are reading your data, so here the land got faulted, structure got scrapped here. We refer that as faults, first breakage, and we refer this region as main central thrust. So remember, this is Greater Himalayas, this is Middle Himalayas, and this is Shivaliks. So in between the Greater Himalayas and Middle Himalayas, we have main central thrust. A broken structure which is vulnerable for large amount of the energy which is releasing there. And the region between the Middle Himalayas and Shivaliks, we refer that as main boundary fault. Main boundary fault. Right. And then the third one, where it created the last one, the last fault, we refer that as the Himalayan frontal fault. Himalayan frontal fault. So because of this characteristics, because of this characteristics, Himalayas have many faults, broken rock strata, and hence it is vulnerable for earthquake. So it is the area where the two plates are meeting, and it has also created three major thrusts, which is associated with the huge impact in the Himalayan region here. I hope it is clear. Now, beyond this, UPSC will not ask anything about earthquake and why the Himalayas are vulnerable. Aftershock, main shock will be having highest one. So here, when we talk about magnitude, so magnitude or whenever energy is released, main shock will be of highest magnitude. After that, of less magnitude. Only the main shock will have highest magnitude. Is it clear now about Himalayas? Many questions can be asked from this. Once you read that, once you fix that in the mind, then you will not have any problem in answering any aspects of Himalayas. So that's why we say Himalaya is most vulnerable in the context of disaster. Is that clear? Fault means broken. This is a rock. When this rock breaks, we refer this as fault. In geography, fault means breaking. Fold means bending. Bending of the rocks, we refer them as folding of the rocks. Himalayas are fold mountains with faults. And hence, when you read Himalayas, the Himalayan mountain ranges are called as tectonic valleys. Tectonic, plate tectonic. So they are longitudinal and tectonic valleys. And tectonic. And this is all based on what we refer them as plate tectonic theory. Is that clear? So many terminologies were there with reference to earthquake and these things. Right. Now we move on to causes of earthquake. So when we talk about causes of the earthquake, we can put them into two categories: natural. Yes, main central thrust will experience maximum one. Is it clear? So when you're reading your current affairs now, so if you're reading your current affairs, you will come across these: main central thrust, main boundary fault, Himalayan frontal fault. So they will talk about these points. UPSC may ask a question, write a note on the faults in the Himalayas. And this is very simple way of representing. You don't have to use any technical terms here. Right? Natural. In the context of natural reasons, it is plate tectonics. Second, huge volcanic eruption. Volcanic eruption, we refer them as natural causes of earthquake. Then we also have anthropogenic factors or man-made factors. Now in the man-made factors, it is about constructing of the dams, so when the dam is constructed, huge water will accumulate, and that accumulated water will destroy the isostasy. Dam construction will destroy the isostasy. So what is isostasy? Isostasy is a state of equilibrium which the Earth's lithosphere maintains with the asthenosphere. This is your geography part. Isostasy, that is state of equilibrium. Right. So construction of dam, whenever dam is constructed, huge accumulation, it will destroy that balance. One area, huge accumulation of water that destroys that, which makes the breaking up of the faults, so which create faults. Crack in the lithosphere. Second, it can be due to mining activities. Or maybe due to nuclear tests. of very high proportion. Or sometimes when we use a method called as fracking or hydraulic fracturing to extract the shell oil. Fracking or hydraulic fracturing to extract shell gas. Shell gas. So these are the man-made factors. So this you have done in your SNT, SNT or in basics geography, extraction of the shell gas by a process called as fracking or hydraulic fracturing. India do not have such activities. US and many developed countries are doing. Fracking or hydraulic fracturing is used by US and many countries to extract the shell gas which is inside the earth. Now these events which are referred as anthropogenic or man-made, anthropogenic or man-made. So they are also referred as induced earthquake. They are also referred as induced earthquake. Induced by human activities. Induced by human activities. So if they ask a question, write a note on induced earthquake. Never mention natural earthquakes. Natural earthquakes are different. Induced earthquakes are different. So induced earthquakes are associated with something like this. Right. So this is what you have to remember. See, when we talk about shell gas, don't expect me to give all the details of your SNT, basics of geography, because this is your disaster management class. In the disaster management class, if I keep on explaining all those science topics and basics geography, then it becomes very difficult for me to cover entire topics, right? As they are all your SNT and basics geographies. So if you are good enough in basics geography and basic science, see, isostasy is also your basic geography. All these are your basic terms. If I keep on explaining isostasy, then hydraulic fracturing and all, then it becomes very, very difficult for me to cover all the terminologies there, right? Now, I'll try to explain that in a very simple word. Try to understand them. The first one is about isostasy. Now, when we talk about the Earth's division, I told that, or in the geography, we have something called as lithosphere. And this lithosphere is floating on asthenosphere. This lithosphere is floating on the asthenosphere because asthenosphere is not a solid part. So it is just like big ship floating on the water body. So it is floating on the liquid part. It is floating on the liquid part because of the principle of buoyancy. It maintains the state of equilibrium. Buoyancy, it maintains the state of equilibrium. Equilibrium, that is balancing. Now, when we see the Himalayas are there, when we are standing on the lithosphere, so in the lithosphere we are standing, we never get jerks. Why? Because the lithosphere maintains the stability, equilibrium, stability or equilibrium with the asthenosphere. And this state of equilibrium, this state of stability is referred as isostasy. So the state of equilibrium is referred as isostasy. Now, when this stability is destroyed, then the earthquake takes place, or we refer that as an earthquake. Now, this is destroyed by many factors. Like on the lithosphere, if you construct a dam, so big dam is constructed, which will accumulate large water. Or sometimes very huge infrastructures are created, like Dubai buildings, etc. Huge buildings are constructed. Right. Now, it is maintaining a balance. It is something like this. You are having a wooden plank, and above the wooden plank, you are sitting which is maintaining a balance and which is floating on the water. Now, on one corner of the wooden plank, if you add huge amount of weight, what will happen? Will it maintain its balance? On one side, if you put all the weight, will it maintain the balance? Does the wooden part, will it maintain the balance? So it will get disturbed. It can't maintain that. Right. Now, this is what happens in the dam construction. So whenever dam construction is done, so the weight which was maintaining, the buoyancy get disturbed. So this buoyancy get disturbed. Right. Now, the moment when the buoyancy get disturbed, it will develop a crack. And crack is nothing but fault. It will develop a fault. And this fault is nothing but earthquake. Narmada, where they say constructing of a dam can create fault lines. So then they say that as we construct dams, so dams are vulnerable for earthquake. So generally we say the dams are associated with the earthquake or seismic activities. And this we have seen in the context of Koyna Dam of Maharashtra. In 1960s. So whenever that balance is destroyed, when it breaks, energy is released. And that is called as the induced earthquake. Is that clear? So this is something which is associated with the isostasy and man-made impact, which breaks that. So generally, this isostasy is destroyed either by constructing of a dam, mining activities. When you drill that, isostasy is disturbed. It will break that. Or sometimes, maybe due to some other activities. Is it clear? So remember this. It is the impact of human activities. So I hope it is clear, Dhyana, isostasy. Right. So when we say balance, in the sense, it is based on the buoyancy. If you are good enough in your basics 8th, 9th physics, you will understand what is buoyancy. Buoyancy is if it displaces the equal amount of water, what its weight is, it will float. Simple as it is. I'm using the term buoyancy. Buoyancy means it has to displace the water which is same as its weight. Then only it will float. If it is less, then it will sink. Right. Now, something called as shell gas and all. So when we talk about shell gas, and all, please understand this. In the context of shell gas, this is the surface of an earth. Now here, in the earth's interior, we have many rocks. Big rocks are there. So in the big rocks, these rocks which are there, they are porous and non-permeable. Porous means they can accumulate, but they are non-permeable. They will not allow the liquid to flow. Non-permeable means moving of the liquid. If it is permeable, the liquid will accumulate in one area. So here, as they are porous and non-permeable, so in this case, the minerals will be accumulated. The oil or the gas is accumulated in different areas. So they do not have permeability. So they will be in different patches. And you can't drill independently and take out the shell gas. So shell gases are extracted from shell rocks. They're extracted from shell rocks. And shell rocks have the characteristics of porosity and non-permeability. They are porous but non-permeable. So the mineral here, the petroleum or the gas, is scattered. So they all are scattered. Right. Now what you should do is you should accumulate the scattered one. Now how to accumulate that? You can accumulate that only when you make a linkages of that. So what the technology is, the technology is, so here first they will drill here, they will make a drilling, and after drilling they pass hot water, chemicals with pressure. So when they pass the hot water and the chemicals with the pressure here, what will happen? When the huge pressure is done, huge pressure with hot water, we refer that as hydraulic. So whenever high pressure water is pumped inside, high pressure water, when it is pumped in the crack of the rock, so what will, when it is entered into the rock, it will make the cracks. So this will make the cracks. High pressure will develop cracks, and this is called as cracking with pressure. Now the moment when the cracks are developed, all the natural gas, all the minerals which are there will accumulate in one area, and then it is extracted. And we refer this as hydraulic fracturing. We refer this as hydraulic fracture or fracking technology. It is not in India. US has used this fracking technology and it has become self-sufficient. It has become self-sufficient in shale gas. Why? Because such types of the hydraulic fracturing or fracking phenomena are seen in US. And that's why if you are reading current affairs, in California and many areas, we find the fracking activities are responsible for minor earthquakes there. Minor earthquakes there. Now UPSC may ask a question: what is fracking, what is hydraulic fracturing, and what are the major issues associated with the hydraulic fracturing? Hydraulic fracturing will have major issues is pollution of groundwater. As it is pumped downward, pollution of groundwater will be there. And it will also create induced earthquake, man-made earthquake, which can be more dangerous. Now, in context of India, we don't have technology, we don't have financial part. In context of India, we don't have technology, no technology and financial issues, plus these things. So you can write with the for and against that. Is it clear now what is shale gas and fracking? Bhavna and all those who were asking about the shale gas and fracking. Is it clear now? Shale gas is a gas which is extracted from shale rock. Now, what is the characteristic of shale rock? It is porous and non-permeable. And the method which is used to extract that is called as hydraulic fracturing or fracking event. Is that clear? So this is how you have to read your current affairs. So a lot of the things are there where you have to read from your current affairs rather than making in-depth analysis. These are all are new terminologies. Why? Because China has large amount of shale gas. If you are reading your current affairs, China is having large amount of the shale gas. Now, if we talk about shale gas there, if China develops fracking technology, then it becomes a major game changer in the context of in the deep sea, the petroleum is extracted not by fracking. In the deep sea, it is extracted by normal processing, like in the context of India, when we take the Sagar Samrat in Mumbai High. So here it is accumulated. In the deep sea, the petroleum is accumulated and it is easy to extract. But here, a process is involved. in the deep sea and all, it is accumulated in one area, and wherever it is accumulated, it is extracted easily. Here it is not accumulated. You have to make first accumulation. It means you have to make the rock permeable. And how the rock can be made permeable? By developing a crack. So you have to make this rock permeable. You have to break the rock, and then it will accumulate, and then it is extracted. Shell gas has become self-sufficient. In US has become self-sufficient. So if you are reading your current affairs, before 2000, US was the largest importer of petroleum. US was the largest importer of petroleum before 2000. After 2000, US has developed the fracking technology, and it has become self-sufficient in shell gas. Now it is no more importing the petroleum, because it has sufficient amount of shell gas which is there. Now, because of fracking, because of hydraulic fracturing, and because of self-sufficiency in US, the present country which is importing more amount of petroleum is China, followed by India. So after that, US, when it has become self-sufficient in 2000, now the China is the largest importer of petroleum, followed by India. So India and China are there. Now, in case if China develops the fracking technology, then it will be a game changer, because much of its financial assistance are given for importing of the petroleum from Middle East and all. Now, if China develops the fracking technology, then it will not have to depend on Middle East for their energy resources. Energy resources. And if you are reading your current affairs, China has large amount of the shell gases. Only thing is, they have to develop a technology which can be win-win for environmental and for their perspectives. These all are your current affairs, plus what we refer them as geopolitical consideration. Whenever when you are reading your international relations, whenever when you are reading your, say, current scenarios, focus on current aspects. This is where, if you understand the present geodynamics, your preparation becomes simple as it is. We have shell gas, but we don't have technology. That is where I'm taking you. Current affairs are very important. Godavari, Krishna, everywhere on the earth we are having shell gas, but we don't have technology. And if we use the technology, then we will have a problem. Already India has a shortage of groundwater. Then when we use the technology, then we will have a major problem of that. We will have a major problem with that. Now, such questions will be asked in your UPSC examination, in your SNT, or in your geography. Like, shell gas is a gain, or fracking is a game changer in the present geopolitics. What are the major constraints associated with India? The major constraint with India is we don't have technology, financial issues, pollution, earthquake problem. So that will be a more dangerous in the context of India. So always read them with your current affairs. And as this is an disaster management, please remember, disaster management is a summary of all. And if I keep on explaining these, then it becomes very difficult for me to cover entire terminologies. Anyway, is it clear now? Fracking, its geopolitical consideration, why it is significant, how it is a game changer, why US has become self-sufficient, why it is a major threat for the present consideration if China develops that, why India do not have fracking, why India is lacking this. We have that shell gas is there in Kaveri Basin, Krishna Basin, Godavari Basin, but we don't have the technology. We don't have the technology. If you are reading current affairs, you will find that shell gases are there. We are working on that. We are working on that. ONGC is working on that. Right. So we refer them as the natural as well as man-made factors. So natural are plate tectonics and volcanic. Man-made factors are anthropogenic, or we say dam construction, equilibrium, etc. Is it clear, or still any doubts on this? Because these are very important for your current affairs and geopolitics. That's a topic only earthquake, but these are very important. This is a game changer in the present scenarios, associated with something called as the environmental concern. Okay, don't worry. So if that is the case, then I'll take up one class on Saturday. So one class, extra class, I'll take up on Saturday. I'll just check with them, and then if it is feasible, we'll discuss something like that. Wherever lackings are there, don't get stressed. Even don't get stressed. So if they are not covered, I'll try to see, and we'll have one session on that. So if it is required, then we will cover 1 hour, 2 hours session on Saturday. So if any such doubts are there, you can make pile up them and you can ask me. Done. But now, is it clear, or anything which is pending here regarding the earthquakes, the Indian part? Why more earthquakes are there in Himalayas? Definitely 100% you will expect question from that. Why more earthquakes in Himalayas? What types of earthquakes are there in Himalayas? Right. Okay. Don't get stress. Don't get much stress. Focus on discussion. And don't worry, if it is required, I'll take up 1 hour or 2 hours extra on Saturday and we'll cover that. Done. Then global distribution of earthquakes. So when we talk about global distribution of earthquakes, we always talk about the global distribution of earthquake with reference to what we refer them as three belts. Three belts are there. I don't know about that, Prem. I'll check them. I'll check and ask them to revert back on the recorded classes. The first one is Indian plate and African plate colliding with the Eurasian plate. Indian plate colliding with the African plate, and African plate colliding with the Eurasian plate. So this is referred as the first belt, called as Alphide belt or Alpine Himalayan belt. We refer this as Alphide belt or Alpine Himalayan belt. Indian plate and African plate colliding to that. Alphide or Alpine Himalayan, both are same. The second one is the subduction of the Pacific belt. Subduction of the Pacific crust or Pacific plate. We refer that as circum-Pacific. Circum-Pacific, or we refer that as Pacific Ring of Fire. Circum-Pacific or Pacific Ring of Fire. Alphide belt, circum-Pacific or Pacific Ring of Fire. Right. Now the third one is you don't have to write in detail about that. Third one is you can mention others, including induced earthquakes. Others including induced earthquakes. Now you should be very, very careful in your points. Induced earthquake means man-made earthquake. So it can be here. We refer them as man-made earthquakes. So three distribution of belts are there. Alphide belt, circum-Pacific belt, and other belts including this. So always keep this in the mind. Right. Now, if you are reading your current affairs, so here we find the incidence of Taiwan earthquake, 2024, Taiwan earthquake. Then, if you are reading this, so here you will come across the earthquakes associated with the Turkey and Syria, this region of 2023, and here the Himalayan earthquakes of 2023. And apart from that, remember this Alphide belt, it consists of shallow and intermediate earthquake. It consists of shallow earthquakes and intermediate earthquake. Right. And if you see the Pacific Ocean or the circum-Pacific belt, it consists of all the three types. All three types: shallow, intermediate, and deep focus earthquake. defocus earthquake, right? Now, apart from that, they also ask why Indonesia is often and often associated with more earthquake. Why Indonesia is often and often associated with earthquake and tsunami. Right. Now it's simple to remember. Indonesia is most vulnerable for earthquake and tsunami because it is sandwiched between the two powerful earthquake belts. Which are the two belts? It is sandwiched, clubbed between two belts. It is sandwiched between the two belts. Two belts. Now, which are the two belts where it is sandwiched? Can anybody mention that? Indonesia is sandwiched between the two belts. Right. Alphide means African and Eurasian plate. Both are there. African plate colliding with and Indian plate colliding. We refer that as Alphide or Alpine Himalayan belt. Right. Alphide and Himalayan belt. Now, this Indonesia is in between the Alphide belt and Circum-Pacific belt. Pacific belt. So here we find the Indonesia. If you see this region, Indonesia. So it is a part of Alphide belt, and it is also the part of the Pacific Ring of Fire. It is also the Pacific Ring of Fire. So Indonesia is more dangerous because of its location. It is sandwiched between the Alphide belt and Circum-Pacific belt. Yes, that Pacific and Indian is part of Circum-Pacific belt. Now, don't get confused. Harika, what you are telling is correct. Pacific and Indian plate subduction is there. But this Pacific and Indian plate, this is Indian Ocean, this is Pacific Ocean. This is Indian Ocean, this is Pacific Ocean. Now, the Indian Ocean and Pacific Ocean, that is part of Pacific Ring of Fire only. So, this entire ring is Pacific Ring of Fire. Entire ring is Pacific Ring of Fire. Belts are different, plates are different. Belts means the name given to the region where the earthquakes takes place. So boundaries of the plates are referred as belts here in a very simple term. All the plates are not associated with earthquake, but these areas where the earthquakes are dominant. Is it clear, Harika? So when we talk about the belts, you should not mention the Pacific and Indian belt. I'm talking about belt, not the plates. I'm talking about belts. Is that clear? So Indonesia is sandwiched between two belts. Plates means it is Indian plate and Pacific plate. I'm not talking about plates. I'm talking about belts. So it is between the two belts. One is the Pacific Ring of Fire, that is horseshoe shape. And second one is what we refer them as Alphide belts. So it is between the two belts. Alphide belt, that is Alpine Himalayan belt. And second one is Pacific Ring of Fire. Right. So this is about the global distribution of earthquake. Plates, these are plates, two plates which are meeting. This is a belt where we find large amount of activities takes place. Right. So this is global distribution of earthquake. Distribution of earthquake. You can take a break, then we will start at 8:05. Don't get much stress. You should be very, very careful with your terminologies. Once your terms are clear, once your contexts are clear, then you don't have to break much head on that. Right. So this is what we refer them. So you can meet up at 8:05. So welcome back after a break. So hope I am audible as well as visible to you all, right? This is the write-up of the global distribution of earthquake, Alpha belt, the Pacific Ring of Fire, and the terms which are there. So please read that. Now next is impact of earthquake. What happens when the earthquake takes place? Now loss of lives will be there, damage to the infrastructures, electric short circuits, and the fire in the urban areas if it takes place. Then it can trigger landslides in the mountains, landslides in the mountains like Himalayas and all. Then flash floods if it takes place in the mountains where glacial lake outburst floods are there. If it takes place in the mountains where glacial lakes are there. Glacial lakes. When the glacial lakes breaks, it will create gulfs. In the mountain regions. Then sometimes if the earthquake takes place in the ocean or water bodies, it can lead to tsunamis. So we'll discuss what is tsunami later, right? It can lead to tsunamis. Then something called as soil liquefaction. So soil liquefaction is a process. Generally, wherever we find the area which is having a land with certain amount of saturated waters are there. In normal characteristics, in normal properties, the soil is very solid and rigid. The soil is solid and rigid in the normal condition. And this will support the buildings. It will support the buildings. But sometimes because of the pressure, in the land which is having saturated water, in the land or the soil which is having the water. So because of the pressure here, the soil loses its rigidity. The soil or land loses its rigidity. Rigidness or toughness, and it behaves like a liquid. It loses its rigidity and it starts behaving like liquid, which do not support the infrastructures which are standing on them, and that will make the infrastructure to collapse. So this will make the infrastructure to collapse. Large buildings collapses because of such types of impact. We refer that as soil liquefaction. Soil liquefaction. Many buildings where their foundation itself is destroyed by the impact. The solid nature behaves like a liquid part. It will not support the standing buildings. When the support is diminished, then the whole building will collapse. We refer that as soil liquefaction. Soil liquefaction. Is that clear? So these are the impact of earthquakes. And whenever the damages are there, whenever collapsing of buildings are there, so these creates physical harm to the people, which are responsible for lives and injuries. The debris, etc., will have a huge impact on human life, animals, and that area. Saturation means not about mixing, not about its carrying capacity. Saturation means the land area which is having water availability. The land area which is having availability of water, which is having water, which is inside that terrain. Due to the pressure, the solid nature is destroyed. Solid nature is destroyed. It loses its stiffness. Now you don't have to make in detailed analysis. Just remember that They will not ask any engineering part. Just remember, due to the impact of the pressure, wherever saturated land or soil which is saturated with the water is there. So because of the impact pressure, the soil loses its rigidity, its stiffness, and it behaves like a liquid, which will not support the standing buildings, and the standing buildings will collapse. That's how the losses are seen in the context of earthquakes. Right. So the impact of earthquakes. Next is, in the context of India, as a part of preparedness and all, we also created something which is referred as the maps, which are created by Bureau of Indian Standard. See, flash floods in the mountain areas, when we have the glacial lakes, in the mountain areas, it is having glacial lakes are there. In the context of earthquake in these mountain areas, it will break the glacial lake, and the glacial lake will generate glacial lake outburst floods. Bureau of Indian Standard, it has classified the entire India on the basis of intensity, into zones. Initially, there were 5 zones, but after 2002, zone 1 and zone 2 are combined. Zone 1 and zone 2 are combined. Then zone 3, zone 4, and zone 5 are there. So hence, combining zone 1 and 2, we refer that as zone 1 only. And zone 3, zone 4, and zone 5. So hence we say, at present, entire India is divided into 4 zones. Zone 1 and 2, zone 3, zone 4, and zone 5. And this is based on the intensity. Intensity means the losses. Zone 5 is of highest intensity. Zone 1 and 2, lowest. Right. Now, if you see the entire data which is given by National Disaster Management Authority, it says that out of the total geographical area of India, around 59% is vulnerable for earthquake. 59% is vulnerable for earthquake, with different intensities. Zone 2, low risk. Zone 5, very high risk, like Himalayas, neighboring areas, etc. So 59% is vulnerable for earthquake. And in that, you should remember, zone 5, 10.1 or 11%. Zone 4 is 17%. Zone 3 is 30%. Zone 3 is 30%. So please remember. So most dangerous one are zone 4 and zone 5. Zone 4 and zone 5. And what makes India's earthquake more dangerous? The nature of the earthquake. In India, generally we find shallow earthquakes are there. Shallow earthquakes are there. And sometimes intermediate earthquakes. But most earthquakes are shallow earthquakes, like the earthquakes of 2023. They all are shallow earthquakes where Indian plate collided with the Eurasian plate. Right. Now, when you are writing answers, please keep this in the mind. Now, why vulnerability is high in India? Because of India's population. According to 2011 census, we are second most populous. Then economic disparities are more here. And large amount of economic activities like industries and agriculture. We have industry and we have agriculture also, which are something which are associated with losses. So hence India has, if any earthquakes takes place, there is always possibility of huge losses due to density. If you see the national capital region Delhi, the population density is more. So if any type of building collapses are there, deaths will be obviously more, injuries will be more. So hence we find it is major thing to be taken into consideration. Is that clear? So please remember these things, right? See, when we talk about the economic part means it is about agricultural sector, industries, manufacturing sectors, etc. So in the context of India, industries are there, factories are there, manufacturing units are there, and there we find huge money is invested. So during the earthquake, when these are affected, then we say it brings economic losses. Economic losses. Is that clear? Because in the Delhi region, industries are there, refineries are there. So if they start, if any impact of earthquake is there, then they will bring losses in that region. Is it clear? So please represent these. So when we talk about intensities, I told you very clearly in the beginning, intensity means it is about the losses. And these are the numbers. More than 9. Intensity of 8. Intensity is always shown from values 1 to 12. Yes, they will be having the index. Don't go with that. They will be having index. If it is a geology, if it is a geology, then there will be more. So there is something called as a factor which is seen. They calculate them with certain factors. They calculate with certain factors. Don't go in depth about that, right? So it is based on certain geological terminologies. Don't go with one. See, Northeast having more because it is a plate where Indian plate has collided with the Eurasian plate. This is again your basic geography. In geography of state, Himalayas is covered in how many states? If you understand that, then your entire geography question will be done. How many states the Himalayas are covered? Himalayas, extension of Himalayas. Himalayas extension. So at the moment when we say 7, so in that 7, don't you think that northeastern states are there? Right. So 11 states, including northeastern plus 2 union territories. 2 union territories. 11 states plus 2 union territories. That is Ladakh and Jammu and Kashmir. Is that clear? Dikshit, why northeastern is more? Because it is a part of Himalayan belt. Done. So please remember this map. Remember that map. Himalayas, entire Himalayas, zone 5 and zone 4, and Gujarat region. Then the remaining areas. Practice this map 1 time, 2 times. So anytime whenever you are writing answers, immediately draw this map. That is more than sufficient. Now next is earthquake part. Now in the context of earthquake, do we have any early warning system? Can we create any any early warning system in earthquake? We don't have any early warning system. So hence it is about preparedness and mitigation. Right. So it is about preparedness and mitigation. See, when we talk about zone 5 and all, it is all based on the geological impact. So if we take all this area, do we find any mountains which have been collided? So this is an area where the Indian plate collided with the Eurasian plate. So hence this is a very small area which is around 11%. So 11% is associated with zone 5. Now preparedness and mitigation is very, very important here because we don't have early warning system. No early warning system. Only thing we can say that this region is vulnerable for earthquake. We can't say when the earthquake can hit that areas, right? So hence preparedness and mitigation is very, very important. Now in this context, the government has started earthquake monitoring center. So we have created a network of earthquake monitoring system, and this network is created by Ministry of Earth and Science. It has created a network of these, and these are referred as National Center for Seismology. National Center for Seismology. Seismology. Now, I hope it is known that seismology is study of earthquake. Seismology is study of earthquake, right? So National Center of Seismology. So we are having a network of National Center for Seismology, and there are more than 100 centers are there, and more than 100 centers are established in different areas, and they always provide regular monitoring and dissemination of information. Regular monitoring and dissemination of information. Because we don't have early warning, so you have to make a proper monitoring and dissemination of the activities there. Then vulnerability maps, like the hazard map, which is developed by Bureau of Indian Standard. Right, the moment when you prepare vulnerability map, then you can restrict certain types of settlements. So you can restrict the settlements. You can also restrict certain type of activities like construction of dams and other. You can also restrict certain type of activities. Right. So we refer that as the vulnerability map. The moment when you know that that region is vulnerable, why you will allow the people to construct the dams? Why will allow the people to construct their settlements? Right. So vulnerability map. Then effective dissemination of vulnerability risk information. Right. So this is based on the previous studies. Based on previous studies. Previous data. And by that you will conclude them, and then you will try to give them in the proper ways. So this is done by many methodology. The collection of data and all can be done by using GPS, global positioning system. And during the earthquake, we also disseminate by using certain apps which are very significant there. And for that, the Ministry of Earth Science has developed a map or an app which is based on the data which is accumulated and based on the vibrations which are seen. And we refer that as India Quake Web. India Quake App. Right. So this will help the people to understand. And also we have something called as the Google and NDMA has developed an alert system. Google and NDMA has developed an alert system. So in the mobiles, you will get that alert if any vibrations are there, right? So alert systems are given. Alert systems. And again, this can be improved more when we have more sophisticated one, like launching of NISAR may give more input on that. Then structural and non-structural measures. The same thing. Structural means we have to make sure that structural means earthquake resistant building. Earthquake resistant building. Or else whatever old buildings are there, you increase the strength of them. We refer that as retrofitting. Retrofitting. Right. So earthquake resistant buildings has to be constructed. It means codes are given. Bureau of Indian Standard, along with the Griha, along with the TERI, they have constructed certain codes. And these codes, they help us to understand what quality they have to maintain? What minimum quality they have to maintain? Apart from that, in the year 2019 and 20, India has also done something which is called as CDRI. CDRI. So CDRI is Coalition for Disaster Resilience Infrastructure. Coalition for Disaster Resilience Infrastructure. So I'll take up what is CDRI tomorrow, but understand CDRI, resilience. Resilience means two terms: resisting and recover quickly. Resilience always have two terms: resist or quick recovery. They may ask a separate question on CDRI, Coalition for Disaster Resilience, and this is an initiation where India is part of that. India has initiated that Coalition for Disaster Resilience Infrastructure. I'm repeating, Coalition for Disaster Resilience Infrastructure. So their standards are met when we are constructing any infrastructure. So I'll discuss that CDRI tomorrow in detail, because you can expect question from CDRI as it is India's perspective. So we refer them as structural measures: resistant buildings, retrofitting, coalition for disaster resilience. Now, what are non-structural measures? So in the non-structural measures, again, it is about budget, leadership, training, awareness, etc. All those we refer them as non-structural measures. It is about budget reallocation, training, awareness, etc. We refer them as non-structural measures. So when you're writing your notes, always keep a list of structural measures, always keep a list of non-structural measures. In most of the disasters, they will be overlapping. In most of the disasters, they will always be overlapping. Structural measures, if not, non-structural measures will be 100% overlapping. Policies, capacity, they all will be there. So once you make a non-structural measures, they are perfect for all disasters. Structural measures, you have to vary. When you're talking about earthquake, in the earthquake, mangroves will not be there. So in the earthquake, retrofitting and all. If you're talking about cyclones, mangroves, embankments will be there. So certain non-structural measures will differ, but all the structural measures will be overlapping. All the structural measures will be overlapping. So when you're making your notes, make a list of all structural measures, and then non-structural measures, segregate them. What non-structural measures if it is earthquake? What non-structural measures if it is cyclones, floods, right? What non-structural measures if it is something called as tsunamis, right? So divide them, make a sure shot data of that. Then you don't have to write again and again for your mains. It is about the accumulation of data which is overlapping with all the disasters, right? Then rescue and relief measures. Rescue and relief measures. Now here it is associated with the same NDRF, National Disaster Response Force, right? And also critical facilities which are given. And this is done by, again, local people, coordination, right? This is done by proper coordination, awareness, local people, etc. So we refer that as rescue and relief measures. Again, I'm telling you, all the disaster managements will be the same. Only thing is you have to check which disaster they are talking and what non-structural measures are there. Then where you have early warning system, where you don't have early warning system. What is risk and what is crisis. Right. 6 pillars of earthquake management. This is what we refer them as retrofitting. This is an example of retrofitting. Retrofitting, right? So it is earthquake resistant construction standards, then selective seismic strengthening and seismic retrofitting, like iron walls, seals, etc. Regulating and enforcement. Regulating means restricting certain type of activities, enforcement of certain activities. Awareness and preparedness. awareness and preparedness, pre-disaster management, because we don't have any type of early warning system. So the best one is you have to prepare and create the awareness among the community. Then capacity development by education, training, and documentation. This will increase their preparedness past. Then emergency response and capacity enhancement. So whatever we have been discussing, the same data will be given in the statement. So these are referred as the 6 pillars of earthquake management, not only in India, in entire world. Then critical areas. Critical areas means issues in the earthquake management in India. This is general observation what we have seen. The critical areas means the problems. Lack of awareness among various stakeholders about seismic risk. Awareness is very less. We know that the earthquake will happen, but awareness is of very less quality. We don't know what we have to do in the event of earthquake. We don't know how to take care of pets. We don't know how to take care of ourselves. We don't know how to get out of the panic and take the conditions in the normally. So lack of awareness among the various stakeholders. Inadequate attention to the structural measures. So here in the context of college education syllabus also, if you're talking about education syllabus also, we are not given a separate criteria for them. So inadequate attention is given. We are not created, even in the engineering studies also, we are not created in detailed aspect of that. Lack of awareness. Then inadequate monitoring and enforcement. So proper coordination is required. It can be building codes, or it can be town planning, or any laws. We don't have proper coordination. They should be clubbed and they should be coordinating with each other. Absence of system, licensing of engineering and masons. Now, if you see the masons and engineers in the context of India, a person who is constructing the building, the person who is joined there as a normal worker, after 10 years of experience, he will become a class 1 contractor without having any experience in his any engineering experience. He will construct that. Right. So we find these masons and all, they don't have any licenses. They don't have any prescribed norms of licenses which they can construct the resistant buildings. Right. So this is a general trend which is being seen. A person works for 10 years, then automatically he will construct, or he will start becoming himself as a major mistri there. And then he will take up the orders for constructing of the buildings as an engineer, but in spite of not having his courses, in spite of not having the certification for authorization, he will start constructing the work. So we have such types of laws. Even in the Himalayas also, if you visit Himalayas, if you check the person who is constructing the buildings in the Himalayas, the person who is constructing, he will not be having a complete knowledge of the retrofitting buildings. He will not be having any type. Generally, they start that. So we have to at least make sure that the person who is constructing there, he should have certain idea, right, which type of construction should be done. And this was very systematically done in Taiwan. If you see the Taiwan, in the 1990s, the losses were very huge. But now, in spite of the magnitude of 7.4, the losses are less. Why? Because they have used systematic construction, systematic licensing, and they have adopted a best type of retrofitting buildings in that areas, or building codes which are maintained where they are resistant to the earthquake. Collapsing are comparatively less. So hence, if we compare the data of 1990 and the data of 2024 in Taiwan itself, in 1990, the deaths were huge, but in 2024, the losses were less. They were less than 9, right? Is it possible to prevent? No, it's not possible. You can't prevent the earthquake. So never mention the point, prevention of earthquake. You can't prevent. You can't prevent that. Kutch and Andaman Nicobar Islands. There also you find, because Andaman Nicobar Island is an extension of Himalayas. If you have read your geography, so extension of Himalayas are in the Andaman and Nicobar. Right. Then absence of earthquake resistant features in the constructions. We don't have such, because the person itself has not specific knowledge. Then how we can construct that? Then lack of training and preparedness among that. Right. So you can't prevent, but the casualties can be reduced by proper mitigation and preparedness. So these are the major issues associated with earthquake part. Kalburgi in Karnataka is prone to earthquake. It is due to man-made activities. Where, if you see India's part, right now in the context of India, the main is where Indian plate collided with the Eurasian plate. And if you take the Indian plate, this is Gondwana plate. And what is the age of Gondwana plate? It is the oldest one. It is the oldest one. Oldest one means it is having the age of more than 350 million years. More than 350 million years. Sometimes 400, 500 million years. So it is the old rock strata, which might have lost its stability, or due to man-made activities. It may develop cracks. It may develop the faults due to its age and due to man-made factors. Is that clear? So please remember these two. So many activities are involved to that, endogenetic activities and human. So generally age factor, where it is losing its capacity. Second one is man-made factors, which are also responsible for triggering minor earthquakes in that areas. Like sometimes you come across mining activities, any areas where mining activities are there, many areas where we find huge amount of accumulation of water followed by accumulation of water, which disturbs the isostasy, by which we can find a small amount of lower magnitude earthquake strikes there. Generally, we find not only in Kalburgi, even in many areas in Bangalore also, we find that where we find mining activities, where the rocks are bombarded, where we find quarrying is done. So in the areas of quarrying activities, so we find man-made earthquakes are dominant there. In Kalburgi also, we find quarrying activities are there, mining activities are there, which can induce a small amount of earthquakes in that areas, mining, quarrying, or sometimes due to the age factor. Is it clear now? Yes, it's not about Kalburgi. We find in many areas we find that. Like in California, it is due to fracking. So in other parts of India, it is due to mining, quarrying, dam construction, Koina Dam, etc. Okay. Now we move on to tsunami. Is that clear, or any doubts there regarding earthquakes and all? Stephen, Atish, Beamrise, all. So do we have? Yes, done. Because these are the topics you don't have content. But if you are accumulating all the information, then it is very easy. In geography itself, you have said Indian plate colliding, extension of Himalayas, Arkandioma in Myanmar, Andaman Nicobar in the south. Done. Now we move on to tsunami. Now what are tsunamis? The moment when we say tsunamis are nothing but series of the waves. Tsunami is a Japanese term. It is a Japanese term, which is referred as harbor waves. Harbor waves means series of waves. Yes, it is a real tsunami image. It's a real tsunami image. Ziba, don't take in detail about cyclone warning centers and 4 cyclonic centers. All they are having different criteria, but they are used for defining, because it is based on their intensity of giving the information. As I told you that in the context of India, the northern Sirkar is vulnerable for tsunamis, cyclones. And if you talk about the Utkal region is associated with extreme cyclones, right? So based on their parameters, they are defining. So don't go in detail. If in prelims they ask, just remember the points. So we have cyclone warning systems in the east coast as well as west coast, right? Okay. Now when we talk about the tsunamis, it's a Japanese word called as series of waves, right? Now When we talk about the tsunami, understand that tsunamis are referred as series of waves. Now, in the context of tsunami, there is always a huge displacement of water takes place in the coastal areas. So, tsunami is huge displacement of water in the coastal areas. In the coastal areas. Why? Due to series of waves. Due to series of waves. Now, why the waves are developed? Next is why the waves are developed. Why the waves are developed? Now, the waves are developed. Waves are developed because of undersea earthquake. Undersea earthquake. Landslides in the water where it disturbs the static portion of water. Volcanic eruption. Now, volcanic eruption in the sense, if this is an water body and here this is an volcano. Now, because of volcanic eruption, which has erupted there. Now, take an example of volcanic eruption last week, Mount Luna. So, whenever volcanic eruption is there, the slope of volcano can fall in the water. The rigid slope of volcano, it will detach from that and it will fall here. Now, this will create a waves. So, it is collapsing of a slope. So, this is volcanic eruption, collapsing of a slope, which can create one. Now, second one is very important. This you have already done in your geography. Now, magma is having very high temperature. Now, during the volcanic eruption, the magma which is having very high temperature, say around 1500 or 2000 degrees centigrade, this magma comes in contact with the water. Now, understand here. If the water's temperature is increased tremendously, what will happen to the nature of the water? Water is there, which is boiling. If you increase the temperature of water to say around 100 degrees centigrade or 50 degrees centigrade, if you increase the temperature of water, what will happen? Now, expansion is when you are heating it slowly. When the temperature increases, what will happen to the water? When you heat the water, then what will happen to the nature of the water? Will it remain same in the liquid state? It will remain in the same liquid state. What will happen? So this water will convert itself into steam. So when the magma interact with the water, when the magma is interacting with the water, so this water will become superheated steam. This magma, when it combines with the water, it will become superheated steam. Now, whenever the steam is there, when the huge water has become steam, it means huge latent energy is there. Then will that area will be normal? What happens when the steam accumulates in the cooker, in the pressure cooker? You have a safety valve. If that valve is not working, what will happen to the accumulation steam in the cooker? What will happen to the cooker? Right. So if accumulated steam is there, accumulated pressure will be there. It will burst. Right. The same thing happens in this. It will explode. Now here also the same thing. When the magma comes in contact with the water will become superheated steam, and this will create an explosion. And such explosions in volcanic activity, we refer them as phreatic explosion. Generally, we see them in the volcanic activities which takes place in the inside the water, right? So like Indonesia, etc., so where we find this is a water body, and here we are having, this is volcanic part. Now in this volcanic part we find the magma. It comes in contact with the water, and that will create phreatic explosion, huge explosion, huge explosion. And this is where the tsunamis are developed. And very classical example of this is, you might have heard about the Honga Tonga volcanic eruption. The Honga Tonga eruption, or sometimes they say Honga Tonga. The largest volcanic eruption which was seen, most violent type of volcanic eruption in the year 2022. Honga Tonga eruption. And this will make huge amount of waves here. So the phreatic eruption, the phreatic explosion in Honga Tonga created tsunami waves in the neighboring areas of Australia and those. So we refer them as volcanic activities. So volcanic activities are something which are associated. Yes, it has reached to the mesosphere. That is a dangerous part. So that's what understand how strong this explosion will be. So it is not a normal explosion. It is not a normal explosion. The explosion was so huge that the gases, the dust particles reached even the second layer of the Earth's atmosphere. You forget troposphere. It reached stratosphere. It reached stratosphere, and small traces have reached to the mesosphere also. So understand this. So it is not a normal explosion. It is called as phreatic explosion. Is that clear now? Collapsing of the slopes or phreatic explosions, they can trigger the volcanic activities. They can trigger the tsunamis in the water bodies, right? So the moment when you say volcanic activities, please remember these terms. And this slope event we have seen in the year 2024, last week it is there, and this is an evidence of 2022. We have got live examples how the volcanoes can trigger to the part. Now earthquake means, earthquake generally, when we say, not all the earthquakes, major earthquakes. And which type of earthquakes can be dangerous? Deep, shallow, or intermediate? Which earthquake? Major earthquake means earthquake of magnitude 6 and above. Earthquake of magnitude 6 and above. Perfect. So it has to be shallow, or in the worst case intermediate. Shallow earthquakes are more dangerous. Shallow earthquakes are more dangerous. So if it is shallow earthquake of magnitude 6, 7, it is just like blasting a bomb in the surface area. Perfect. So this is where then we have something called as meteoritic impact. A big meteor, when it is falling to the water bodies, so they will trigger the waves. Then many unknown causes are there. You can leave this unknown causes. At least you can remember these. Rather than unknown, you can say other causes. Other causes means, sometimes we say nuclear test which is being done there. Nuclear test which is done underwater, or many other activities. So generally we refer them as other factors. Now the next and very important is, why tsunami waves are dangerous than the normal one. Why tsunami waves are dangerous than normal. Now don't mention global reason. Don't mention global reason for tsunamis, because tsunamis is a huge displacement of water in the series. Never mention them as landslides. Can be mentioned. Landslides can be mentioned due to earthquake. Landslide is when the landslide is there, huge amount of land collapses and falls in the water. If a stagnant water, if you throw a stone, it will create a ripples or waves. But if a whole building collapses, if a whole mountain collapses and falls in the water, don't you think that it will create a ripples? So we refer that as landslides. Like how the slopes of the volcano falls, the land neighboring mountain will also fall on that, which can create the huge amount of tsunami waves. Is that clear now? Landslide and how it is associated with earthquake. Underwater and land based. Underwater is This land is a part of a mountain, part of a mountain. See, part of a land collapses maybe because of the earthquake which has taken there, or maybe because of heavy rainfall, maybe because of heavy rainfall. So part of a land collapsing referred as landslide in the mountains. If the mountain is near the ocean areas, landslide can trigger. Is that clear now? Landslides, maybe due to earthquake, or maybe due to sometimes you may find glacial avalanche also. A huge glacial falls in the water, which can trigger the tsunami. Huge glacial falls in the water, triggers the waves. So it is about disturbing the water phenomena. Now, why the tsunamis are dangerous? What is the reason behind them? Why they are more dangerous? Now, when we talk about the dangerous perspectives of the tsunamis, again, this is your basics of your geography and basics of part. Please remember this. In the context of tsunami waves, most of the times they will ask the energy of the tsunami waves. The energy of tsunami waves is embodied. Embodied means found, clubbed, integrated. Embodied energy is embodied in its wavelength, amplitude, and the phase. Now, when you're talking about amplitude and all, understand, if this is a waves, the highest point is referred as amplitude. Amplitude means height of a wave. Wavelength means the distance between the two crests, or the distance between the two troughs. We refer that as wavelength. Wavelength, right? Wavelength. Now, why the tsunami waves are dangerous? The reason is the tsunami waves have certain peculiar characteristics. They travel with high velocities in deep water without losing energy. They travel with high velocity in deep water without losing much energy. Without losing much energy. They travel very high velocities without losing much energy. Right? Because in the deep water, they will be having very huge wavelengths and less amplitude. Because they will be having wavelength which will be very high and low amplitude. Low amplitude. It means you don't find the height of the waves. You don't find the height of the waves. They travel very fast. If a boat is there, it will also not identify that the tsunami has occurred here, because velocity is very fast. The height is not there. The ship or vessel will not have any type of impact also. As the wavelengths are very fast, it will travel. Now, apart from that, a very unique thing about the tsunami waves is, if any change in any of the component, if any changes has occurred in any of these wavelength, then it will make compensating adjustment in other two. If changes occurred, compensating adjustment is done. Compensating adjustment is done in the remaining factors. It is something like this. If the ocean water is deep, then it will have long wavelength and small amplitude. Something like this. So this is an ocean, so amplitudes will be very small. Nobody will realize that. So wavelengths will be very long and amplitude will be very small. This is if it is deep water. Now, the moment when the water becomes shallow, then compensating adjustments are, its velocity decreases first. It travels with high velocity in the deep water. The moment when the water becomes shallow, its velocity decreases. Now, as the velocity decreases, its wavelength decreases. Its wavelength decreases. Wavelength decreases. Now, the moment when the wavelength decreases, what will happen to the amplitude? Compensating adjustment is done. What will happen to the amplitude? As a basic common sense, if the wavelength decreases, what will happen to the amplitude? Amplitude will become high. Amplitude will become high. That is, the height of the waves increases, and that's why they become dangerous. That's why they become dangerous. Right? So it is something. This is an ocean. This is an ocean. And this is where we find the waters are there. Waters are there. Now focus on understanding. Now the earthquake has struck here of magnitude, say 7.4. Here it is deep water. Deep water. So after that, this will create vertical movement and horizontal movement of water. We refer them as the waves. So it will create the movement of water, displacement of water, vertical as well as horizontal. So here initially it will have long waves. In the deep water, long waves, long wavelength, and very small amplitude. Very small amplitude. So hence, it is very difficult to identify the tsunami in the beginning stage. So that's why they say possibility of tsunamis. It's very difficult to identify tsunami in the beginning stage because of this factor. Now, when the waves moves to the coastal area, when the wave is moving towards the coastal area, now towards the coastal area, when it is moving, what will happen to the water? The water, is it still deep or it is shallow? When the wave moves towards the coastal area, the waves, when it moves to the coastal area, then the water will become shallow. Then what happens? The velocity of the wave decreases. So its velocity decreases. Then second thing is its wavelength shrinks. Wavelength decreases. Now what will happen to its amplitude? Amplitude will increase. So here the height is not that fair, but the moment when it reaches here, its height increases. Its height increases. So amplitude becomes high. So hence the tsunamis develops the waves of great heights. And after that, its energy collapses. It can't transfer the energy. After meeting to the coastal areas, all the energy is transferred in the form of high waves. And these waves enter into coastal areas. These high waves will enter into coastal areas. Like the episode of Chennai or Tamil Nadu in 2004. High waves will enter. And this phenomenon is referred as shoaling effect. Shoaling effect. Shoaling effect. Is it clear? So we refer this as a phenomenon associated with tsunamis. So this is what the tsunamis are more dangerous. See, Ramwat, if any doubts are there with my classes, I can clear it instantly. Now, regarding your optional part, I'll communicate this to the concerned authorities. I'll talk about that. So, which is your optional? You tell me. I'll communicate to them. People, I'll communicate to them. Right now, regarding my subject, disaster management or somewhere geography or ecology, if you are having doubts, I can immediately clear them. Immediately I clear, because these are certain things which are associated, and I'll communicate to them. So energy is converted, it is not used. Energy here, energy is converted into amplitude. Energy of the wave is converted into high amplitude, and these high amplitude, high waves, when they enter into the coastal areas, we refer them as flooding. So this creates flooding in the coastal areas. Flooding in the coastal areas, and hence we say the tsunamis are more dangerous. This is how it takes place. That's how it becomes dangerous one. And this extra water, when it enters, is something which creates the major problem. If the global temperature increases, then it will create cyclones, not tsunami. It will create cyclones. Tsunamis are not associated with global temperature. Tsunamis are associated with these phenomena. Right. Tsunamis, instead of that, you can mention cyclones. Tropical cyclones will increase. Don't confuse cyclones with tsunamis. Tsunami is different, cyclones are different. Is that clear? So this is all about your cyclones and its characteristics. Right. This is how the earthquake has taken place. Then the waves travel, low amplitudes, very difficult to identify. And then when they reaches to the coastal areas, we refer them as shoaling effect. After reaching to the coastal area, the energy of the wave reaches into the amplitude, and after that, when it makes the waves to fall on the coastal areas, all its energy ends up there. All its energy ends up here. So in geography, when you read about the waves is nothing but it is the energy which is transferred from ocean towards the coastal. Wave is a simple definition of wave is it is nothing but the energy which is transferred from ocean towards the coastal area. If you read the definition of waves, energy is transferred, and after reaching to the coastal area, it disseminates, it puts in the coastal region there. So here also the same thing. Here also the same thing. Amplitude, and then entire water, when it reaches to the coastal area, its energy is. So in simple terms of geography, the wave is nothing but it is the transfer of energy. When the winds or when such events are there, its energy is transferred from the ocean towards the coastal area. Is that clear? So this is all done by taking many perspectives. Right. So keep this in the mind. Now here we use many technologies, like satellites are used. We use many type of technologies. Satellites are used in the context of understanding the data or collection of the data. Right. Many methodologies are also seen in the context of giving early warning system, because these waves, when it develop, they take time to reach to the coastal areas, and hence these areas for tsunamis, early warning system can be given. Yes, until when it reaches to the coastal area, then only the impact will be there, right? If it is not reaching, then how the waves are stopped? Right? It has to disseminate its energy. It has to disseminate its energy. Right. Now, impact of tsunamis. What will happen? Loss of lives, damages to the infrastructure, degradation of natural resources like forests or water bodies. So whenever water bodies are there, the lakes are there, the ponds are there, the saline water enters here. Right. Saline water enters here. Right. Then when the saline water enters, the soil will lose salinity. The agricultural soil, it will lose its fertility. It will lose its fertility. the soils will become saline, and hence fertility is lost. Right. So we refer them as natural resources. So natural resources means, example, land is a natural resource. Drinking water is a natural resource. So when the saline water enters in the ponds and lake, they are not suitable for drinking. The land will become saline. Productivity decreases. Like, so loss of livelihood for farmers and fishermen, because here we find these areas are always associated with livestock resources, and they will always have an impact on the farmers and fishermen's ecological impact. So the submergence in that area, so whenever tsunamis are there, the submergence will be there, and this submergence will have huge impact on the areas. Now whenever when we talk about the tsunamis, which areas the tsunamis create more dangerous, or how the impact of tsunamis are seen? Again, its impact is not uniformly distributed. Any areas where, like what you are seeing in the cyclones, if the population density is high, they will be most affected. Second, based on economic activities. Then third one is the shape of coastline. Right. So which coastlines are more vulnerable for the tsunamis and cyclones? Which type of coastlines are most vulnerable for tsunamis and cyclones? Broad or narrow and elongated? So that should be kept in the mind. So whenever when we talk about the density, economic activity, shape of the coastline, it is always the narrow and elongated coastlines. Narrow and elongated coastlines are always affected. So hence, whenever when you're writing your answers in the context of tsunami, you should keep this thing in the mind. Impacts of tsunamis, like loss of lives, damage to the infrastructure, degradation of natural resources, etc. Right. So we refer them as impact of tsunamis. I'll communicate that, Ramwat, regarding your anthropology. I'll communicate that. So whatever concerned subjects are there, I'll be talking, and whatever your queries are there, I'll be communicating to them. Arun, Ramwat, I'll be communicating. I'm reading that. I'll just tell them that these are the queries. Is it clear? So impact of tsunamis. Now, if you see the India's vulnerability, India has a long coastline of 7,516 kilometers, and also population which is there in the coastal areas. Now the two regions are there. Two regions are there where we find India is vulnerable for the earthquake. And these two regions are, the first one is Indonesia and Sumatra subduction zone. Indonesia and Sumatra subduction zone. And this was somewhere in the year 2004 when the earthquake of magnitude 9.2 triggered the tsunami in the Chennai and Tamil Nadu region. So the first one is Indonesia Sumatra subduction zone. Sumatra subduction zone. And remember, it is a mega thrust which was seen in the year 2004, a magnitude of more than 9. Then the second one is this area, which can also trigger the tsunamis, and that is called as Makran subduction zone. Makran subduction zone. Right. So India is vulnerable for tsunamis because of two. One is Indonesia Sumatra subduction zone, and second one is Makran subduction zone, which can trigger the tsunamis, not only in India, in other part. So please remember this map. So whenever when you're writing vulnerability of tsunami in India, draw this map. Indonesia, Sumatra, and Makran subduction zone, Makran coast, Makran trade area, east of Saudi Arabia or Arabian Peninsula, northeast of that. This is Arabian Peninsula. This is northeast of Arabian Peninsula. Makran subduction zone. Is that clear? So this is about India's vulnerability. Now we move on to tsunami management in the context of India. National Disaster Management Guidelines. Now, tsunami risk assessment and vulnerability analysis is done. And this is done. This is done by National Disaster Management Authority. And this is based on coastal area. This is based on coastal land use and the water depth in that areas. Coastal land use, you can say coastal land use map and depth of a water. Now, when we talk about the depth of a water, so sometimes when we study the depth of a water, we refer that as which term in geography? In geography, when you are studying about the depth of the waters or deep waters, we refer that by which term? Deep water studies. So maybe in your oceanography, you are studied about that, the deep waters. We refer that by a term called as bathymetry. Bathymetry. So based on coastal land use map and bathymetry, tsunami risk assessment and vulnerability is done. Now this is done by taking the previous data. Now this is accumulation of all the factors, the INSAT, the present one, the past one, the change in the population in that area. Tsunami preparedness in the sense, when we talk about preparedness, it is always making the local people increase their capacities by knowledge base, training, etc. Early warning system and forecasting. Now in the context of early warning and forecasting, again, whatever information is there, it has to be disseminated, it is to be passed by using many apps. Like here we are having maps called as Sagarwani. Sagarwani map is used to give the information about the movement of tsunamis. And also sometimes if any earthquake is there, India Quake map or India Quake app. Right. And apart from that, these early warning systems are forecasting are strengthened by using latest technologies. And this is by accumulation of the data from satellites like INSAT, Indian National Satellite. The data is accumulated from that, or from the surface water movement. So taking data from INSAT, surface water movement, etc. It will help them to create early warning system. And then it is forecasted to the people. Then structural measures and non-structural measures remains the same: policy, awareness, budget reallocation, etc. Structural measures, it includes artificial embankment, natural embankments like mangroves, artificial embankment, shelters, wave breakers, etc. Right. So these are the things which you should remember. Wave breakers, removing silt, all these are included in that, so that the coastal area phenomena are maintained here. Right. Non-structural measures, including the coastal regulation zones, etc. Right. So tsunami management and guidelines in the context of India. Right. Now, whenever when we talk about early warning systems, we take the data from international tsunami warning systems and also regional warning systems. So international as well as regional. So we depend on both that. So both the data will give sufficient part which can help in creating a forecast and communicating that, right? Now, whenever when we talk about the satellites traces the movement of water inside the ocean. They traces the movement of earthquake inside that, and then they will disseminate that to the centers by which they can create the forecast, right? Now, management of tsunami in the context of India, early warning system plays an important role, and this is developed by INCOS, the one which I read in cyclones. The same thing is Hyderabad, right? And this ITS comprise of a real network seismic stations, integrated tsunami early warning systems. ITES means integrated tsunami early warning systems. Integrated tsunami early warning systems, or India's tsunami warning systems. India's tsunami early warning system. Early warning system. It consists of network, real-time network, which consists of bottom pressure recorders, and tidal gauges. Bottom pressure recorder and tidal gauges. Then it can detect large undersea earthquakes in Indian Ocean. It can detect the large one 10 to 20 minutes after the earthquake occurs. So that's why I told immediately you will not find. It will take at least 5 or 10 minutes. When the waves changes their characteristics, then only it can be identified. So hence it is very difficult to identify in the beginning stage. The moment when the earthquake is there, you can't say that it will trigger the tsunami. So generally after the earthquake, they say there is a possibility of tsunami. They say there is a possibility of tsunami, right? So hence it is very difficult to predict the tsunami in the initial stage. So hence after 5 or 10 minutes, it can be seen. Is tsunami predictable? Yes, it is predictable, but after 10 minutes of the occurrence, you can predict that. You can predict that. Then Intergovernmental Ocean Commission of UNESCO is making a mock drills. It is doing the mock drills there. And exercises called as IO wave exercises. IO exercises. In all the countries which consist of the basins, 28 countries in Indian Ocean. Now, this mock drill is like your mock test, like mock test. It is to understand the preparedness of the community, how the communities are prepared. Right. It also talks about all the early warning systems and technology they are working on not effectiveness of that technologies. So we refer them as IO wave exercise. And this was done in the year 2023. And we refer that as IO wave exercise 2023. It is done once in a year or once in 2 years. So last year it was done here. Mock drill means they will check. They will check whether the event tsunami takes place, whether the states of Odisha is prepared or not, whether Tamil Nadu is prepared or not, whether India is prepared or not. So they will assess that, and based on that, they will give the rating, and that will help them to understand whether this concerned country is prepared or not. So it is assessing their preparedness. Mock drill means they will check suddenly if they say if earthquake happens there, if any tsunamis are there, what are your preparedness? So they will check them as a monitoring basis. Right. Now this is how the data is calculated from bathymetry, deep waters, then from INSAT and satellites, and then from the models. They accumulate the data, and then early warning system is communicated. Now here I told that apart from the earthquake, which gives the data from the seismic stations and also from the coastal areas, two important instructions are there: tidal gauge and bottom pressure recorders. Bottom pressure recorders. Now, the moment when you talk about bottom pressure recorders are sensors, key sensors to confirm tsunami. They are the sensors to confirm tsunami. Sensors which are kept. And in the context of India, we have kept the bottom pressure recorders. So we have 4 bottom pressure recorders in Bay of Bengal. 4 in Bay of Bengal. And 2 are in Arabian Sea. 2 in the Arabian Sea, which confirm the tsunami. Then we are having something called as the tidal gauge network. So what is the role of tidal gauge network? So this tidal gauge network, it monitors the progress of tsunami waves. It monitors the progress of tsunami waves. Is that clear? So this is how you should remember. So regarding INSAT, Indian National Satellite, so it is a satellites where they collect the data of the movement of water. They collect the data of surface water and beneath water. So the data is collected about the velocity of the water, wavelength of the water, the phase, the energy of the water. So these data are calculated: the wavelength, the amplitude, how fast it is traveling, whether it is stagnant or whether it is traveling. So these data are calculated from INSATs. And then after that, forecasting is done to the coastal areas. So this is what we refer them as the tidal gauges and BPRs. So India has a tidal gauge network which is spread in these many parts. And the idea of tidal gauge is they are having certain types of sensors, they are having certain types of methodology, data, which monitors the progress of the tsunami waves. Of the tsunami waves. Is that clear? So this is about the survey of India and its tidal gauges. Now these are referred as structural measures and non-structural measures, right? Structural measures like wall and breakwaters. These are called as breakwaters. You are breaking their velocities. Mangroves and other vegetation. Mangroves. This is without mangroves. See the water as inundated very deep. And here the mangroves, they act as a first line of protection to them. So hence mangroves are referred as bioshields. First line of protection. Which will reduce the impact of waves. If there are no mangroves, then the water will enter into the coastal areas. Then shelters and relief centers for the people who are affected there. then local knowledge centers, then roads and all, so that the services, critical services, reach to that areas. Then non-structural measures, which includes mapping, training, implementing coastal regulation zones, awareness, and all. So all these are referred as the non-structural measures. So that's what I told you. Whenever when you are making notes, make them structural measures and non-structural measures. So structural measures and non-structural measures, most of the time they will be having overlapping in that. Is it clear? Now, this is all about what we refer them as the natural hazards or natural disasters. Now, next is something called as man-made hazards. Now, the moment when we say man-made hazards, I'll just give an introduction of this. Man-made hazards. So these are the hazards which are done by human involvement, maybe due to error, or we say accident, or sometimes they are done deliberately. Deliberate. Now, deliberate in the sense, take an example of the Ukraine and Russia war. That is deliberate. Atomic bomb of 1945, right? Terrorist attack of 2011, deliberate. Terrorist attack in the consortium of Russia, deliberate. So it can be terrorist attack, it can be atomic bomb, it can be war, which are referred as deliberate one. Then errors and accidents. So these happens maybe due to negligence, or no proper designs, or no proper training, inefficient training. Or sometimes accidents like road accidents, etc. So these are referred as man-made hazards. And always remember, these man-made hazards can be avoided. By taking care of these, by strong international laws and regulations, efficient training activities, etc. So they can be avoided. If not, they can be managed. If not, their impact can be reduced by disaster management. Yes, that's what I told. Poor designs in the roadways, nuclear reactors, negligence, inefficient training, etc. So in the man-made hazards, we classify them into chemical, nuclear, and biological. Chemical, you can give an example of Bhopal gas tragedy. Nuclear, you can give an example of this Bhopal gas tragedy of 1984. Nuclear, you can give an example of Fukushima Daiichi of 2011. Or you can give atomic bomb of that, right? Then biological one, you can give an example of the present one, which is referred as COVID. Right? So these are referred as man-made hazards. So we will be discussing these man-made hazards tomorrow. And after this, then the last will is something where whatever we have discussed, the policies and the structures are there, and all the topics which are structures and all, they are having certain facts. Much explanation is not needed there. So whatever facts are there, whatever charts are there, so please go with those charts, and those charts will be having in the context of your preparation. Yes, COVID is a disaster. COVID has been declared as a disaster. So I'll take it up tomorrow. I'll take up tomorrow. How the COVID was classified as a disaster, I'll explain that also. COVID and other parts. So how the funding is done, from where the money comes, how the money is spent. So I'll give a sequence of that. Plus certain facts are there. Don't get much stress. So from beginning of day one till now, whatever you have done, revise that, read them, and update your perspectives, right? So here sometimes you may find prelims based questions, sometimes you may find that, so maybe act they will ask, maybe act they will ask. And again, when you talk about previous year's questions, so their previous year's questions are there, so that I'll discuss tomorrow. So I thought I will complete all this, but the problem is associated with the certain topics which were missed in your, so as there are many constraints with your geography part and all, so which made me to consume lot amount of time here. Right. So those are very important parts. Even the questions which were asked are very important, because without answering them, it becomes very difficult for you to write anything on that. So tomorrow I'll try to complete the remaining syllabus. And if it is required half an hour or 1 hour extra, I'll take it somewhere on Saturday or any one day. If you are having any doubts also, you can accumulate that and you can raise at that point regarding your geography, environment, or something with the disaster management. So revise them. And that weekly test, I think they are giving you with some questions and all. So certain questions are given, and that, so I'll ask them to give the data and all, right? So with this we'll end up the today's session, and tomorrow will be the last session. If possible we'll meet up again for tomorrow, and we'll see if Saturday time permits, then we can discuss. If any doubts of your anything is concerned with this, I'll have a word with them. So if they provide time, then we will have a discussion for 2 hours regarding geography and all those things. So till then, take care and write as much as possible, read them, and whatever data I have given you for disaster management, I think it is more than sufficient. Only updation is required with your current affairs. Read them, revise them, organize your preparation in the context of examination. So we'll meet up again tomorrow. Hopefully we'll try to end. If not, a small session will be there. Till then, take care and bye bye.